In this movie we'll show you how we can import a Dxf file into PartMaster CAD and then create the contours that we require and pass them through to the Wire EDM system. So I've started the CAD system from the desktop, and from the main menu I'll choose Open a Dxf drawing, and then from the folder choose the file that we want. And we need to specify the units because internally the Dxf file doesn't contain any information about what units it was created in. So this one was created in inches. Okay, so that's the Dxf file there. If I just zoom in on this part here. Okay, so there's a couple of things that we need to do. We need to create contours of as many shapes as we need to cut. So if I just use the mouse wheel just to zoom into an area here, for this example I'll just do a couple of the cavities, but the same thing applies to all of them. So if this is going to be the start hole here, then what we would need to do is to break that horizontal line at a perpendicular position so that the wire can start at the start hole and then move up onto that. So to do that we use Intersect, Split and Perpendicular. So if I choose the center of that in near snap mode, then that will automatically just break that line apart. I don't need to do that for circles, but if I was cutting these other cavities then I would. So we need to create a contour. Now a contour is our word for a polyline. So it's a series of linked line and arc segments. So we go into the CNC mode, and the first thing we need to do is to set up where we want our datum point for machining to be. So this is normally a convenient location on the material. So we can choose a corner, or we might choose a tooling hole as our datum position where XY0 will be. We then create the contours. So we'll start off with this contour here. So as I move the mouse over, then you can see that it's picking up the individual elements. We'll make the line thickness a bit bigger so that we can see it, and we'll make the distance, the Z depth, 1.25 inches. Okay, so what happens is that if there's no anomalies within the shape, then it'll create the contour automatically, but if there's multiple lines or something like that drawn, then we need to indicate them. So that's created the contour there, and we'll do a similar thing on this circle over here. It knows that we've selected a circle and asks us to specify a start position. 0 degrees is 3 o'clock, which is as good a place as any, I guess. So that's done that, and we could do the same thing on all these other contours, but the principle is identical all the way through. So we'll save this drawing away, and we'll call this sample part, and then we'll go through into the EDM software. So it's a two-stage process. We import the drawing first, select the elements within that drawing that we need to pass through, and it's only those elements that we machine. So we go into the EDM module. So what happens is, from that entire drawing, in this instance we've only got the two contours that we've created. Now what happens is that it automatically creates a machining operation for each contour that it finds. Now we need to go into each one of those machining operations, which is called a go round command, and set the parameters. So if we do the first one here, so this is a single contour as opposed to a double, which is full 4-axis. So we're cutting in the forward direction, and if this is a cavity, then the wire will be offset to the right. Under the Options tab, if we need to set a wire inclination or wire angle, then this is where we do it here. The pilot hole is specified here, and it's a distance away from the start position of the contour. So I'd measured this earlier from the drawing, and it's 0.2 of an inch. The lead in, lead out, we can have a linear from the pilot hole to the first position on the contour. We can have a linear plus an arc, or we can have a rectangle plus an arc. So on some controllers it won't allow you to apply wire offsets if the first move is tangential to the second. So in that case you'd either need a linear approach, or you'd have the rectangular, which consists of 2 lines and then an arc. So that's setting the lead in, and you can set the lead out to be the same or different. As opposed, when it comes to the approach movement, we can specify generator settings and feed rates for that. If we need to do multiple cuts, we specify the parameters for a finishing allowance for a finishing cut, the generator settings and offset registers for that. If we need a middle cut, we do the same thing there, and if we need a rough cut. So that allows us to cut up to 3 passes per shape. If we need more than that, then we simply cut and paste the go-round operation, and we can have as many contours as you need, or number of cuts as you need. So that's done the first one, so we can see that it specified the pilot hole there, and it puts it on the correct side because I specified the offset. Now I do the same thing to the small circular contour, set the offset to the right. Under the options tab, specify the pilot hole position. If I need to, again, I can set up any lead in, lead out parameters, approach movements, and so on. So that gives us a fairly straightforward plan view. If we look at it in the isometric view, then we can see it there. If we need to run the 3D simulation, then we click on the button here. And that produces the data to pass through to the simulator. And then we simulate. So when this loads, then it gives us the wire guides and the stock. If we want to make the stock transparent, we can do, and therefore we can see what's happening. The video controls at the top here are fairly straightforward. This is the speed indicator here, play, rewind, reset, and so on. So it's really a question of just running through that. If it's too fast, then we simply slow it down and reset and run it through again. Okay, so that's created the wire path for that. If we needed to cut angles on here, there's 2 methods we can do this. The easiest method is to specify a wire angle when we are cutting here, and then on the machine we can cut one pass with the wire on, which will be for the clearance, and then we switch off the taper cutting on the machine and reset the Z heights to cut the land. So that's just a simple thing which you do on the machine. Okay, so as you say, we can machine all the rest of the contours using exactly the same method, but that's how it works. Or the last thing would be to post-process that for your particular machine tool. This is for a FANUC controller, but we have post-processors for virtually all machines that are available. So that's the G-code file that gets produced. A header section here, then a wrap it to the first position with thread wire. If you have automatic wire threading, then that can be incorporated within the G-code file. And then when it gets round to the end of the first cavity, it gives us the option to stop the machine, cut the wire, wrap it to the next position, and then rethread. And then the same thing happens at the end, cuts the wire before it goes back to the start position. So the post-processor can be modified to output the commands that you need. When we're creating the wire path, we don't produce any technology files or any command files. It's just the geometry, which can then be incorporated into your technology and command files on the controller.